Hi guys, it's Mrs. Gregerson, and as you know, I'm probably out and about on the senior trip. But even if this is 3 years later, I don't really care as much as the fact that this is a great, just quick review of some of the key skills you should have learned from Chapter 9 that will help prepare you for your test. And so you're going to be doing this. I'm going to ask you to do it with a partner in class, and then I'm going to do this video. But I want to know that everything you're looking for will be on the module. So look for this title, Video Links for Test Chapter 9 Review, in the Chapter 9 module of Academy Central if you want to watch this over again. So it's just one of those key things that will help you. I know Mrs. Prempis is also putting this one in her Academy Central because we feel it's just a good tool for you guys to have. So remember, one of the first things you probably should do no matter what when you're doing this is to write down your 3 trig ratios for any right triangle. Remember I said any right triangle. That's what we're going to be working with these. And so the first one we learned was the sine of an angle. And we knew that was opposite leg over hypotenuse. And then we also remembered our ratios. Cosine of an angle is adjacent leg over hypotenuse. And then we have our tangent of an angle, which is going to be the length of your opposite leg over the length of your adjacent leg. Now, some of you don't need to write that out. Some of you just quickly write like what you learned in Algebra 1. You just go SOHCAHTOA. You know that's a quick saying that will help you remember these at no problem. And plus, since this is right triangles, I just want to give you a hint. Always review your Pythagorean triples as well. And over even break, remember, review those because they will help you. So here would be like an example of one of your problems that you're going to have. It says complete the following trigonometric ratios for angle A and angle B from the given diagram. But first, find the length of segment BC. So I'm looking at this triangle, and I need to know the length of BC so I can write my ratios. So I look at this, I'm like, oh, there are no special right angles like 30, 60, or 45, so I have to use the Pythagorean Theorem. Hopefully, you notice, so I'm going to call it side X, that quickly you're like, oh wait, what am I doing? That's a 5, 12, 13. So that's a 12 is the length of the segment BC. But if you forgot, you need to come over here and you need to do the Pythagorean Theorem. And remember, always putting your hypotenuse in the correct location over here. So I get 25 plus x squared equals 169. If I subtract 25 from both sides, I get 144. Take the square root, x is going to equal 12. So that was very easy for us to get. But I'm going to put it here in the diagram because I need to use it for each one of my angles. So first, let's do angle A. And in angle A, I'm going to let that be what I use in green. And I just realized I grabbed the wrong green marker. So we're going to go red. We just quickly changed the color. So angle A is going to be in red. And remember, the key with these is actually get a marker that works, is the fact of knowing for which acute angle what side is what. Now, hypotenuse will always stay the hypotenuse, but my opposite and adjacent sides change. So for angle A, segment BC is my opposite, and segment AC is my adjacent. So when I start plugging these in, I start setting them up. So the sign for angle A is going to be opposite leg over hypotenuse. So I'm going to go opposite over hypotenuse. So that's 12 over 13. Now, here's a word of warning that will help you on your test. No, you're going to have to reduce some of the fractions. Not all, but you might even have radicals in them and stuff. So make sure you review your notes when we went over these. That will be very helpful, but always double check. So I get 12 over 13. Then I get the cosine of angle A, and that's going to be adjacent over hypotenuse. So that's going to be 5 over 13. And then we have the tangent of angle A, and that's going to be opposite leg over adjacent leg. So the tangent of angle A is going to be 12 over 5. Then we're going to use angle B, and we're going to let angle B be in black here. Okay, and remember, angle A and angle B should always add up to 90 degrees. That helps us solve for missing angles. But so for angle A, my hypotenuse will stay the same, but this will now become my opposite, and this one will now become my adjacent. So I'm going to cross out the red ones so we don't confuse them. So for the sine of angle B, I go back here to my ratio. It's opposite leg over hypotenuse. I'm going to go 5 over 13. For cosine of angle B, I know that's adjacent leg over hypotenuse, so that's going to end up being 12 over 13. Tangent of angle B is going to be opposite leg over adjacent leg. So opposite over adjacent, so it's going to be 5/12. And I double check, can I reduce any of my ratios? No. So I'm in simplest form, so I'm good with that. Also, another hint, I would write either SOHCAHTOA or the ratios like this at the top of my test when I'm taking it so I have it fresh in my head. All right, let's do 3 examples. Now, I am not giving you every example of a tangent, every example of a cosine, every example of sine, cosine, and tangent ones, but I gave you the ones that each type. Now, it could change with different ratios, but the setup for the 3 types of equations that you're going to be expected to solve are given here. And remember, you must always show all 3 steps. Parentheses and things are very important with this, and also making sure your calculator goes with it. So here's some rules for the test that even if I'm not here, you can understand. Sides are going to be rounded to the nearest tenth. That's 1 spot after the decimal. And angles, no matter what, are to the nearest degree. That won't change. And if you're looking for area, go to the nearest tenth. And if you're looking for angles, no matter what, nearest degree. So let's do the very first one together. And a lot of people said what helps them is to always pick out, if this is my angle, what sides are we talking about in that diagram? If this is my angle, this ends up being my adjacent, and this one ends up being my hypotenuse. Then you ask which ratio works with adjacent leg and hypotenuse. Well, that's cosine. So I go here and I write it. Do not miss any of these parts. The cosine of 40 degrees is equal to adjacent over hypotenuse. Now, the problem is we got x here in the denominator of our fraction. And one way of solving this is cross-multiplying and solving for x. Now, I use the properties of proportions instead. And I use the fact that x and the cosine of 40 are my extremes, and we have a rule with the properties of proportions that you may switch your extremes and it's still true. So that's exactly what I'm going to do. I'm going to get x is equal to 6 divided by the cosine of 40 degrees. And that is exactly what you're going to punch into your calculator. So on this one here, I am literally going to go at 6 divided by the cosine of 40, and I always close my parentheses on my calculator. Let me actually clear that so you guys can see it a little bit better. Go 6 divided by the cosine of 40 degrees. And I notice I get 7.83244, so on. But I only need to go to the nearest tenth, so I look at the hundred spot, which is a 3. It is lower than 5, so I just leave it as 7.8. You may use equal signs. I use approximate because I want people to know that I'm rounding. So that's 7.8. Now I look at the next problem, and I'm going to do the same type of approach with this. I know I'm going to show 3 steps. I know I'm going to be graded on those. And I'm looking here, and I realize I'm looking for a side. And if this is my angle, that is my opposite. This would be my hypotenuse. So when I go on that opposite hypotenuse, that ratio is always the sine one. So I go sine of 33 degrees is going to be opposite over hypotenuse. So I get x over 12. Multiply both sides by 12. I get the sine of 33 equals x. And that's what you put into your calculator. So I go over here and go 12 sine parenthesis 33 parenthesis close parentheses. Do everyone see this when we close the parenthesis? Hit enter, and you're going to get 6.53. So I round it to 6.5. So x is approximately 6.5. 3 steps. Now we're going to do where we're solving for an angle. And this is when you use your inverse or arc functions when you're working with it. So here for this angle, I realize this is my adjacent leg because it makes it. And this is my opposite leg because it does not touch it and it's the farthest away. And obviously this is your hypotenuse, but we don't need it. So I just need opposite and adjacent, which is our tangent. I still plug everything in. I get the tangent of x degrees, because that's my angle, equals opposite over adjacent. Now normally I'm like reduce your ratio, but that's not my final answer that I need. So I don't have to worry about it because the calculator will do all the work. So now I'm going to use my arc tangent, or you'll also hear the inverse tangent. And parenthesis, do not forget that parenthesis. Does everyone hear me on this? is 16 divided by 12, parenthesis, equals x degrees. So with that, I'm going to go, okay, x degrees. So that means I'm doing an angle. So let's go plug it in. We go second function, tangent, 16 divided by 12, close parenthesis, hit enter. It's 53.1, so that will round to 53 degrees. Hopefully, that will help us set those all up.